Okay, sir. Now I'm going to talk about the minor topic of my presentation, and the first one is surfactant. And the presentation layout are this. These are the topics I'm going to talk about furthermore. First is the introduction of the surfactant and the other names of the surfactant, its definition, its properties, its examples, its working, its purpose, its natural surfactants, parts, structures, classifications, behavior of the surfactant molecules, emphatic, its introduction, its examples, its uses. It is actually the natural surfactant. Benefits of these surfactants, uses of the surfactants, safety measure regarding the surfactants, function of the surfactants, mechanism of the surfactants, and the classification with the illustration. So first of all, we should know that what is surfactant. Surfactant is basically the short form of the surface active agent. In French, German, and Spanish language, this word doesn't exist, but this term is used to describe to lower the surface or interface's tension. First of all, we should know that what is surface tension. Surface tension is basically a thin film or a layer that are formed on the surface of the liquid due to the attraction of the liquid molecules. If the intermolecular forces are lowered in the liquids or in any molecules, then cohesion forces will be lower. Then the surface tension will be lower. This is the surface tension. And the surfactants are the molecules that absorb to lower the surface tension area of the water. It can be labeled or as soap, detergents, wetting agent, emulsifier, foaming agent, antistatic agent. By definition, we come to know that surfactant is basically such a molecule that reduce the surface tension of the water and help to spread out uniformly. It make water wetty. Compounds that are used in an array of cleaning products for them to lower the surface interfaces of the water. And the properties of the surfactants are it makes the molecule slippier, less likely to stick to themselves, and more likely to interact with oil or grease. This is how it is very helpful in soap, detergent, and other labeled as products. The examples are detergent, alkyl benzene sulfonate, soap, fatty acids, foaming agent, lauryl sulfate, wetting agent, dialkyl sulfosinate, different lignosulfonate. So what is the working of the surfactant? Surfactant basically absorbs and then break the intermolecular forces. And the intermolecular forces are break between the surfactant and water molecules. This is how it is easier for the surfactant to lower the surface tension. And what are the purpose of the surfactant? Surfactant is basically used to lower the surface tension of the water and stabilize the interstices to make the water more wet so that the cleansing action of any product, soap, or detergent can be more effective. The natural surfactant. It is also called biosurfactant or amphiphilic, a substance that exhibits a double infinity, polar, apolar, polar or non-polar duality. It has two parts, just like the soap or detergent molecule does. Hydrophilic, polar. Hydrophobic, non-polar. Hydrophilic is basically contain a heteroatom, which may be oxygen, sulfur, or phosphorus, including a functional group, which may be thiol, alcohol, or etc. there are a lot of functional groups that can be included in heteroatom. And in hydrophobic, which is the water hating part of the natural surfactant, hydrocarbon chains of the alkyl or alkyl benzene are present. What is the behavior of the surfactant molecule? Both soap and detergent are known as surfactants, as we have mentioned the example of the both surfactants below. It is a molecule that contains lipophilic, fat-loving, and which actually this is a surfactant, soap molecule or detergent molecule. We can say that it is the hydrophilic part and it is the lipophilic part. This is the air side and this is the water side. The lipophilic part and the hydrophilic part, we can see the air-water interference over there. And this is the micelle formation, and this is the blood of oil, which is surrounded by the hydrocarbon chain. This is the structure of the surfactant molecule. This is the long hydrocarbon chain, which is hydrophobic, non-polar, or alkyl group or R group. This is the carboxylic group. Here, sodium or potassium or sulfate or ammonia, and anything can be attached according to the desired product or need. Hydrophilic part, it is a polar part and carboxylic group. Hydrophobic has no affinity for aqueous solution. Hydrophilic has affinity for water and is also called lipophilic. Amphipathic. These molecules preferentially position themselves at the water-organic interface due to energetic effect. They are surface active. What is the definition of the amphipathic? This is the natural surfactant, a molecule or ion that possess such type of structures is known as amphipathic, and the examples are stearic acid. What are the uses of the surfactants? Surfactants make cleanser, and it can be added into detergent and soap or any other product in the cleansing agent because it enhances the ability of the cleansing agent by lowering the surface tension. It makes the molecules more slippier and less likely to stick themselves and more likely to attract the dirt and grab it more effectively. It is used in lubricant, ink, anti-fogging, liquids, herbicides, adhesive emulsifier, and fabric softener. In human body, we may see the surfactants. In our lungs, they are, in scientific term, we use the pulmonary word. In pulmonary surfactants, we may come to know that they're in alveoli, they're the surfactants, which are also used to lower the surface tension in the lungs and help us in breathing more efficiently. Without surfactant, there are also many diseases occur in human body. What are the benefits that are used by the surfactant in the detergent? It allows the detergent to mix into water, helping cleaning detergent remove dirt from the surface. With surfactants, soap will not mix the water. It also used as an ingredient in lubricants such as shaving, where they allow razor to remove stubble and help limit irritation. It is also needed in car engine lubrication. Now, what are the safety information regarding the surfactant? As we know that we make many chemicals and there are also many side effects and there are also safety information regarding every topic or everything. And to improve the environmental tools and approaches to develop the innovation methods appropriate to address environmental properties of the personal care and cleaning product chemicals. We also have many safety measures regarding this. The author conclude that there is a risk assessment demonstrate that the substance, although used in high volume and widely released to the aquatic environment, and have no adverse impact on the aquatic to sedimentary environment at current level of the use. What is the function of the surfactant? As we know that surfactant molecules contain two portions, hydrophilic, hydrophobic. The surfactant molecules are absorbed on the surface of the oil, so remove it from the fabric structure. This is the fabric structure and this is the surfactant molecule that is carried around the oil molecule. And then micelle formation occurs and then it is rubbed away so that it prevents the redeposition on the clean surface. Now I'm going to talk about the classification of the surfactant. It is quite lengthy. The first is ionic, non-ionic, amphoteric, polymeric substance. These are further classified into their groups or subgroups. This is the another mechanism or working of the surfactants.
Surfactants. This is the molecule of the surfactants, and this is a micelle formation, and this is the oil or grease, and oil grease are inside of the micelle formation, and the water removed the oil or dirt particle from it. And this is the explanation I've already told you here. As we have knew the classification, first I'm going to talk about the non-ionic surfactants. Non-ionic surfactants, this is the example of the and structure of the non-ionic, sorry, this is the structure of the non-ionic surfactants. This is the structure in the solution, and this is the structure of a compound of the non-ionic. Alkyl polyoxyethylene spans twins. And this is the hydrogen bonding in the water molecule. And this is the explanation of the non-ionic surfactant. This surfactant doesn't bear any electrical charge and often used together with the anionic surfactant. The advantage is that they do not interact with the calcium and magnesium ions in the hard water, and it can used in surfactant production rather than soap for the 50%. The major groups of the non-ionic are explained over here. These are the structure of these, and the chemical reaction are this. Long chain alcohol are reacted with the ethylene epoxide to form ether. This is the ether linkage. This is the formation of the non-ionic surfactants. And what are its uses? It can be synthetic or natural source, have in hard cleaners in many industrial processes such as emulsion, polymerization, and agrochemical formation. It is used in fabrics, washing detergent, both in powder and liquid form. And now the second group, which is ionic, and its subgroup is anionic. It is the most widely account. It is the most widely surfactant used by the commercial. Anionic surfactant is also divided into further subgroups, which are alkyl benzene sulfonate, alkyl ether sulfonate, alkyl sulfate, and soap. Alkyl benzene sulfonate, it is the most common synthetic anionic surfactant that are based on the surfactant chain. So wait a minute for a while, kindly please.
ये
So
पेज
here is the
सीधा हो सकता है
preparation of
मरियम?
the A.
मरियम ये पेज सीधा हो सकता है? जी, अगर इजी है तो
Is it okay now?
ठीक है।
This is the preparation of the anionic surfactants. Here is a benzene, and this is the alkene, or we can use it chloralkene. In the acid catalyst, we may obtain alkyl benzene. Sometimes called detergent alkylate. And the other one is alkyl sulfate. It is used in toothpaste, and this is the structure or example of the alkyl sulfate. This is the hydrophobic part, and this is the hydrophilic part of this surfactant. The preparation are this: alcohol with the sulfur trioxide formed alkyl sulfonate. This is the reaction in which there is alcohol. We can take any molecule, and the OH hydroxyl group react with sulfur trioxide, and we obtain the product which then neutralized with the aqueous sodium hydroxide to form the sodium alkyl sulfonate. And the third subgroup of the anionic surfactant is the alkyl ether sulfates. It is widely used in simple alkyl sulfate, and is also called SLES, sodium alkyl ether sulfate. The preparation are this. The representation of the alkyl ether sulfonate is this. This is the hydrophobic part, and this is the hydrophilic part of the alkyl ether sulfonate. And the last soap. The second group of the ionic part, ionic surfactant is cationic. It has hydrophilic positive tail. That's why it is called cationic. It is produced much lesser quantity than the anion. It's mean that anion are in more vast condition than the cationic one. And the types are ester quartz, monoalkyl quaternary. First of all, I'm going to talk about the ester quartz. They directly quaternized fatty acid surfactants described above and replace the laundry application, and more it has more complex structure in which we can see its structure. It is more complex. This is called ester quartz. What is the benefit of using ester quartz surfactants? It gives detergent their fabric softening qualities. And the second subgroup of the cationic surfactant is the monoalkyl quaternary. It is a simple quaternary system with the ammonium ion. This is the ammonium ion. The alkyl quaternary nitrogen system has alkyl group attached to the nitrogen. We see that this is the long chain, and this is the quaternary amine, and this is the methyl group. This is oil, and the chlorine molecule is attached with it. This is the alkyl quaternary system. The chlorine can be replaced with any other compound, any other ion. It can be used as a fabric softener with anionic surfactant, helping them to break down the interfaces or surface tension between the dirt and the water. Anionic are basically are divided into anionic and cationic. This is the difference between the structures of the anionic and cationic. This is the anionic. It ionic part is basically positively charged. And this is cationic. We can see the difference between the anionic as its outer part is negatively charged and its positively charged. This is the main difference between anionic and cationic surfactants. Amphoteric surfactants. Another name is Zwitter ionic surfactants. And the types of the amphoteric surfactants are natural soap or betaines. Natural soap are alkyl carboxylate lipid, and its equation is this. Here, the hydroxyl group has the hydrogen which is replaced by the sodium and salt formation occurs. Betaines, these are the neutral compound with cationic and anionic, which are not adjacent to one another. This is the equation of the betaines. Here the hydrogen is replaced, is removed, and here hydrogen is obtained. Now what are the application of the surfactants? Surfactants are used in drilling mud disparant, separation process. It has also very environmental control. It is used in the petroleum industry. It is used in oil recovering process. Surfactant production per year is 40 billion tons. It is used in cleansing or detergent agent for the 40%. It is used in food industry. It is used in mining, flotation, paper production. It has a vast application, and a few are mentioned with the descriptions. It can be used in detergent, it can be used in emulsifier, it can be used in a fabric softener, it can be used in ink, it can be used as a biocide, as a sanitizer, and surfactant is in detergent, and in the food it is used as a food emulsifier. It is used as a food emulsifier in the food industry. It can also use in the pesticide formulation. It can also use in herbicides and surfactant usage. This is how this minor topic is ended, and now I'm going to talk about another minor topic, which is